Hey, Mike,
Hey, hey Ria.
how's it going?
I'm good. How are you?
Good, good. Recovering from last week at AWS reInvent.
Yeah, same for me. How was your reInvent this last week?
It was exciting. There's always so many new announcements and features. It's really hard to keep up while you're on the floor, to be honest, but I had some time to
Mhm.
catch in some of the keynotes, which were really cool to hear. How was your experience?
It was exhausting. I feel like I'm still catching up. There's
Yeah.
a lot of running around talking to customers, a lot of dinners and things like that. So it was a lot. And yeah, I got back late Friday night, after midnight, and spent the weekend relaxing.
Yeah.
But yeah, I'm back.
That's awesome, and then it's also the jet lag that's there, but I feel like it's a really good time to just meet customers, especially because it's hard to now that, everyone's working remotely all over the world, so it's just a good place to get everybody together in one spot. Yeah.
Yeah. What was your favorite announcement?
I would say there's a couple, everything relating to AI. One of the new models, which is a Nova model, got released, which is it's pretty cool because it includes like input, like different types of input, like speech, video, text, images, all of that.
Mhm.
And I think it's one of the first reasoning models that supports all of those different types of inputs, especially speech. So that one was really cool. And then Kiro, there's DevOps autonomous agents now and security autonomous agents. So all things Kiro was a big hot topic that last week. Yeah.
Yeah.
What about you?
Nice.
Any cool ones in the serverless area or?
Yeah, I was really excited to see Lambda managed instances launch. That was kind of awesome. Uh, I mean, that's it kind of breaks my brain a little bit to think about it, where, we've always thought of Lambda serverless, right? So there's no servers whatsoever. But with managed instances, there are EC2 instances under the hood that
Mhm.
give you all sorts of additional flexibility. So it's a really interesting offering that we have now. And then durable functions also was pretty exciting to learn about. It's sort of similar to step functions in that you can create like multi-step kind of architectures, uh, but it's all done in code. So it's all built right into your Lambda code. So it's pretty interesting. I'm looking forward to trying that out myself sometime soon.
Yeah.
But
I
yeah,
know another big one was Graviton 5. A lot of customers have been waiting for that. So
yeah, yeah. Tell me about that. What was your takeaway there?
I mean, it's just the best price performant, instance now. So a lot of customers are pretty excited about that. And then as well as like database savings plans in terms of like saving costs. So those are some of like the core services that people have been jumping about pretty.
Yeah, all of my customers are excited about database savings plans. That was a big one, I think, for customers. They're going to be able to do things they haven't been able to do before when it comes to paying for databases. So
Mhm.
pretty cool too.
Yeah.
Cool.
All right. We should get started. So this is our last show for this year. So
Yeah.
everybody that's been, you know, tagging along for all of our previous one. I believe it's our fifth one, right, Micah? I think we've
Fifth or
hit.
yeah, I think fifth. Yeah, I can't believe it's been half a year basically, which is awesome. So I'm looking forward to continuing this next year.
Yeah.
But yeah, last show of the year. We're going into the holidays. It's
Hmm.
all coming around.
Yeah. And this is the perfect time right after reInvent to dive into stuff.
Yeah.
Yeah, let's get to it. So, for folks that are joining in for the first time, my name is Riadani. I'm a solutions architect here at AWS. Been here about 3.5 years, and we just started this show this year, and it's all things builder. It's called the Gen AI Developer Hour. Our motto is build smarter and not harder. So all things, building, debugging, live. It's a fun ride. Um, yeah,
Yeah,
Mike.
and I'm Michael Walter. I'm a senior solutions architect. I am coming up on my 5th year anniversary just after New Year's, so I'm
Yeah.
looking forward to that. I hear I get a updated lanyard, which is kind of fun. But yeah, I've been here for 5 years, also focused on advertising and marketing customers in the enterprise. But I'm really pumped to learn more about agentic development and serverless stuff. Serverless is kind of my jam. So yeah, here we are. So should we introduce our guest?
Yeah, let's do it. So the title for today's show is Excel-lent Agents. To learn more about what it's about, let's have Ilya join us on the screen here.
Let me bring him up here.
Hey.
Hey, Ilya.
Hey, how are you guys?
Good. How are you?
Good. Just quickly introduce myself for the audience. I'm Ilya Marmer. I'm a senior solutions architect here at AWS, and I've been here for over 6 years now, and I have about 15 years of engineering experience before that.
We're really excited to have you on, Ilya.
Thank you. Happy to be here.
Awesome. Do you want to talk a little bit about your background, what your domain expertise has been, and how you kind of got into AI and building with the new IDEs and things like that?
Yeah, well, I guess none of us really have a choice about getting into AI, right? We're all in it. We all have to be in it. Our customers are in it, and I think we're better for it. My background was really always in engineering, specifically in women's fast fashion, so in retail commerce. And I came to AWS, and just the team I was put on was ad tech. So now I've been in ad tech for over 6 years. I've supported a few customers, some very large international customers, and the pace of growth and innovation is really something that I was amazed by. And I think that with what AI is bringing to the table, I think it's only going to grow and it's only going to get faster and faster.
Yeah.
Cool. I see we have someone from Morocco watching. Awesome. If you're listening in today, throw in the chat where you're listening from or watching from. That would be awesome. And we also have I like this comment. Work smarter, build smarter, learn smarter.
We'll have to update our motto to add that in.
Yeah, I like that one.
From the schizophrenic web developer.
Yes. We'll bring this one back up here. So yeah, if you've got if you're from somewhere, Australia. Oh, morning, guys. Is it morning in Australia?
Yeah,
it must be. Yeah, it must be. Good morning. Cool, Ilya. Excited to hear about what you've got to tell us about today. Maybe you could kind of start it off, sort of like I'm really curious about this story that you were describing to me and Ria earlier about where you started from, trying to sort of deal with some of these big spreadsheets and where you've come to today. So maybe just give us a little intro about what you're going to share.
Yeah, I'd love to. Thank you. So the intro is that this really came from a customer request. As a lot of things here at AWS, we work backwards from customers. And this was a real customer request from one of my ad tech customers. Their main problem is that they have thousands and thousands of employees. They have a central AI system, and they want to be able to have their internal folks upload Excel docs. Now, there's no preset format, there's no preset size, so it could be completely anything that they want to upload, and they want to be able to chat to the data that's in the Excel format. Whether it's however it's organized, it can be multi-sheet, it could be completely different formats on those sheets. They still want to have the customer essentially, or the user essentially have a RAG-based conversation, completely in natural language, no writing queries, no looking for data. Just explore the data on their own and ask questions. Now, ordinarily with a text document, that's very simple. With Excel, that tends to be very, very difficult. Now, people are visual. We experience the world visually. And when we look at an Excel doc, whether it's bold font or colors, our eyes are immediately drawn to the most probable location of the data we're looking for. So it's very easy to experience and work with Excel when you're looking at it. We all know that a machine can't look at something. It's always just analyzing what it needs to, where it needs to get the information out of. So the challenge that the customer was having, and they came to me with, is we essentially want to be able to have the LLM that's behind the scenes, whatever it is, look at the data, parse it out as best as it can, and provide the answer to customers. to their internal users. So there is no current solution that just does that really well out of the box. You can't, it'll do some things, but for example, calculating the data, maybe it'll do basic math, but if there is, let's say 2,000 or 3,000 rows or more, obviously in Excel docs, a regular LLM is not going to be able to do that. It requires a lot more resources. So
Ilya,
that was the challenge.
I was going to say that brings up an interesting point, how LLMs struggle with like mathematical accuracy. So is that what this customer saw earlier on? Hence they came to you with this, custom solution. How did we start there? And what was the journey of the customer?
I wouldn't say it was even math related. I would say it was just parsing the data out and being able to link data based on completely different requirements, meaning that one sheet could be very well organized and looks like a database table, and another sheet can look completely different, that not have columns or rows organized like a database table, but just have data that's organized by color, for example. So again, very easy for a human to look at and immediately know the importance, but almost impossible for an LLM to look at it and understand it.
It's interesting. So, I mean, I know that LLMs can handle huge amounts of text. And I know that, even in the early days of like ChatGPT, you can upload, images of charts from an Excel spreadsheet, or even like a picture of a spreadsheet itself. And the LLM will be able to like make sense of it from a like image point of view. But what you're describing sounds more like, how people have like customized their spreadsheets any which way that they want from a more like visual point of view to sort of present in a spreadsheet form what the message they're trying to convey. Is that what we're kind of getting at here? Or is it more about like the volume of data in the spreadsheet that's the limitation?
It's not really the volume. It's more the first and second thing you brought up. It's a combination. So the first challenge is, let's say there is, and I have an Excel document that I'll show as part of the demo. There is 3 sheets of data that are 2 of them are organized as standard database tables. That's what it looks like. Another one doesn't have really column headers, but has completely different information row by row. And the information that's in every row, the subject of that information is in the first column, and you'll see what I mean. And then the last sheet has, again, data that's completely unrelated to each other, to the data that's in the previous sheets, but is organized in a layout that a human will easily be able to look at and immediately be able to understand. But with the lack of organization and structure, an LLM will struggle with quite a lot.
Why don't you show us your spreadsheet so we have a better idea what we're looking at?
Sure, yeah, love to.
Let me bring it up here. There we go.
Yep. So this is the spreadsheet that is part of the demo. This data is just public trading data for a couple of stock tickers. And as you see, the first 2 sheets are organized as standard database tables, like standard Excel docs. We have the headers at the top and then information below. Same for this one. The financial comparison is a little different. So the headers don't really matter, or there aren't any headers, and the topic of each row is on the left. And then the last sheet is even tougher to look at. So it has multiple tables within a single sheet that are organized by brand. So if I was to say to you, give me all the 13F filers for brand 1, you would immediately look at here. Because this data is not available to an LLM in a visual format like we're looking at right now, you can't just do that. There's certain calculations that have to be done, and that the models have to understand what data is in here, and it has to organize it for itself. So that's what we're going to be talking about.
So you also brought up colors in the spreadsheet. So does your solution also take that into account?
No, no, unless the color is indicated somehow in the encoded Excel, which I'm sure it is. I'm just not sure if the LLM can read them with specific colors. Then no, this solution doesn't I have actually never experimented with the colors.
Hmm.
We could probably ask, which colors are red.
Mhm.
We can do that as an experiment if you like.
Yeah.
Cool. All right. So talk to me about like the approach. Like what would you do before the solution you came up with versus like, what you're looking at now?
Well, before, I think a solution would be very difficult, especially when one of the major requirements is that there's no set format. If there's no set format to this data, it's very, very hard to create a program that will try to interpret it without some sort of intelligence like an LLM has.
Hmm.
So I would say a previous solution didn't exist just because of the different amount of formats that are possible when a user is uploading an Excel document. Somebody that lives in Germany, for example, and they upload an Excel document, the the cultural changes that would happen when a user from the US is uploading a document, whether it's colors or formats, dollar signs versus euros, all of that can play a part in how an Excel document is formatted. And one user shouldn't care or have to adhere to a format that they're not familiar with or have never seen. So I would say a solution never existed before LLMs became available.
It
Right.
really hits home for me because I used to work in museums, and museums are notorious for creating super complicated spreadsheets and organizing everything they do, emailing these things back and forth to each other all the time. And when one winds up in your inbox and it's like, what is going on in the spreadsheet? It would have been so great to like
Mhm.
be able to understand it quickly and talk with it, with an LLM. So this is pretty exciting for me.
Every industry and every, domain will be, more efficient with this, right? Because I can't imagine how many hours folks spend analyzing spreadsheets. This is, somebody's full-time job,
Yeah,
right?
or just trying to find where the data could be, because this one is very simple. This is four sheets, right? I've seen Excel documents with 20, 30 sheets with no notes. So good luck finding the data then.
Mhm. Talk to us a little bit about the journey. I know this is a project that, you've been exploring for a little bit now. So as the models have evolved, as the solutions have evolved in terms of, AWS services and all, how was your experimentation from the start to where you are now?
Yeah, so thank you for that. So the even when LLMs were first introduced, when we introduced Bedrock or when ChatGPT was first introduced, there was, even if you uploaded this file and started asking questions about it, maybe you'd get some data, but it was not able to parse out very specific data, or maybe data that was ambiguous to, unless you explained very, very specifically what you were looking for. And when it came to figuring out like averages or the sums of columns of that you pick arbitrarily, everything fell apart completely.
Right.
One of the thing that really helped us help the customer is that we introduced a feature called Code Interpreter within Bedrock agents. So what Code Interpreter actually does, and I'll show you how it handles a file, is it looks at the file that's been uploaded, it looks at what the prompt is, and then it writes and executes code to try to figure out the answer. So as you can imagine, if you're writing code that is going across tables like this, it's very easy. If you ask a model, give me all the averages for the closing price for brand one, that's a very easy query to write, as you can imagine, in SQL, for example, if this was a table. So Code Interpreter does something simple, or something similar, where it will use the Pandas Python library, treat this like a regular data table in a data frame, and write the necessary code and queries to get you the answers you want.
Mhm.
But that's a very, very simple example. Just like it's a simple SQL example, it's a simple Code Interpreter example. It will easily be able to do this. What becomes challenging is if you ask questions around data that's not very structured, and you ask questions that are pretty vague or ambiguous. So one of the questions that we were testing was, what is the average of all 13F filers for both brands? That's it. That's the prompt I would send. And I would send this entire document. So the first thing that has to happen is the model, it can't just go to this fourth sheet called aggregate holding by fund because it doesn't know what the sheets are. The first thing that has to happen is essentially an exploratory phase where the model will look at each sheet, look at the names of each sheet, look at the headers of each sheet, try to organize that data, and then try to actually write more and more code to get to the answer. So
sorry to interrupt. There's a couple funny comments I wanted to pop up here while you're going through this. So Daily Push says, put a picture right in the middle of it, like a company logo, to start helping things fall apart. I thought that was pretty funny.
maybe I'll try that after this.
This one looks, there are a lot more art than science. People get pretty creative when they start building these spreadsheets out, for sure.
And you can do amazing things with spreadsheets. I will never say that Excel is not a very, very powerful tool. I think half the financial industry runs on Excel.
Absolutely.
But LLMs are really, really terrible at parsing the data out. So which brings us to Code Interpreter.
So I know you mentioned Code Interpreter is a functionality as part of Bedrock agents. Can you talk to, the folks here? What are Bedrock agents? What are agents? Folks that might not be as deep into the AI sphere.
Yeah, of course. So Bedrock is a managed service that AWS released, I believe at this point, a year and a half ago. And with that, I think agents were introduced immediately. So agents is essentially a process that will go out and do a unit of work on your behalf. It can run for whatever the limits are in whatever system you're using to manage those agents. But in Bedrock agents, you give it the prompt, and in this case, you upload the file and you let it go. So the agent will try to parse out all the information out of the file first, or at least where the data can be found, and make its best effort to give you the answer. It doesn't always work, but at least you can see how it works and what it's doing. And I'm happy to share that as well. With AgentCore, which is a new service we introduced at NYC Summit during the summer. So this is more of a managed service for running your agents. There's a runtime for agents specifically that run as a container. The timeout is much longer than, say, Lambda functions. So I believe the max timeout is 8 hours. And there's a few tools and a few services that are part of AgentCore, one of them being a code interpreter. So that's the tool that an agent can use to execute code that you've written. So it's a completely serverless, isolated environment. It's similar to Lambda, but the issue is that if you wanted to use Lambda in this service, with this solution, you would have to deploy a Lambda function for every execution. Code Interpreter saves you that time and effort by allowing you to just put code into an environment and get the output out very, very quickly. It doesn't have all the libraries and all the code support that you would want, but it is a very, very powerful tool, especially when we're talking about agent development and what agents can do with that tool. So I'd be happy to share how the old way used to work and how it works in the new way. So if I can stop sharing this, and I'll bring up. The detail here. So this is something that I already asked. So for example, one of the things we talked about in one of our test use cases for that file that I showed you was, what is the average number of total puts for 13F filers? So again, this is very, very vague when you're not looking at the Excel doc and can see everything in one view.
So what are we looking at right here? What
Oh, I'm
interface?
sorry. Yeah, so we are looking at the interface for Bedrock agents in the AWS console. So if you go to Bedrock, you click on agents, this is one of the agents that I have running. And I've already done this test just because we all know a demo can fail during a live stream. So I uploaded the Excel doc I showed earlier, and this was the question I asked. And the reason I wanted to bring this up is, and one of the challenges we faced is, even though this worked, and it's really impressive that this works, the correct answer is 307,000 between the two brands, based on the data that we have in that Excel sheet. The challenge was that it was still pretty slow. Now, is it pretty slow in the sense that, is it slower than a person opening it up without knowing where to look? Probably not. But it is slow in the sense that if you want to build a RAG interface, if you want to build an interface where you're essentially chatting with a document, I would say a 1.5 to 2 minute response is not a great user experience. The beauty of this interface here is that you're able to actually see what's happening with every step. What is the AI doing with every single step of this to be able to get the data out of the Excel document? So you can actually go through this, see what text is being sent, what outputs are, what the metadata is. So here you go. I'll help you analyze Excel files. So what is essentially happening here is the agent is talking to itself and a knowledge base on its own. As I said, an agent is something that does the work for you. So this agent is going to do all this work for me, and it's going to go through several steps. Some of these steps are going to contain code that it's actually writing. So here, for example, you could see that it's using the Pandas Python library to read the Excel doc. It found the sheet that it should look at. And now this is going to say the full view of the aggregate holdings by fund is whatever is in this variable for output. It's going to go to the next step. It's going to write code.
Oh, sorry, Ilya. I was going to say I have a question. So in terms of the prompt that you provided, how sensitive is the prompt? Because it looks like the code interpreter is creating the code based on the prompt, right?
Yes.
So can you talk a little bit about the prompt engineering involved there? Is it sensitive? Is it not? How did you decide upon this prompt?
So there are, and this is one of the main differences between using Bedrock agents and AgentCore to do this same kind of job. So Bedrock agents actually gives you a lot of flexibility, but not enough. So with Bedrock agents, a lot of the processing is under the hood. What models are being used is under the hood. What models the code interpreter will use is under the hood as well. Some things are configurable, some aren't. The solution that uses AgentCore and Code Interpreter directly is much more customizable because you're the one that's responsible for what the agent is doing and how it's going to do it, what models to use, how to write the code, etc. But to answer your question, are you talking about this prompt or what, like this prompt right here?
The original prompt on the left side of the screen.
Yes. So this is the original prompt I asked. That was all I sent. How you word this. So as we know, with any LLM, the more context you give it, the better and faster it'll run. So if I was to say here, what is the average number of total puts for 13F filers from the sheet name where I know the data is, you'd get less traces, less steps, your data would come back faster. But that's not always possible.
Interesting. We're about halfway through our show now, and I thought we could take a few minutes to just recap a little bit for folks who've just joined. I see we have a few more viewers than we did at the start. So we're here chatting with Ilya. Ilya's a solutions architect here at AWS, and we're talking about spreadsheets. We're talking about how to use large language models and agents, and specifically a tool called Code Interpreter to take very complex, very customized, very unique and bespoke spreadsheets and make sense of them. So Ria or Ilya, anything you want to add to kind of bring us up to speed?
Yeah, so we talked about a couple of different solutions. Ilya mentioned that he used Bedrock Agent's Code Interpreter. Originally, when he first got introduced to this problem, he was exploring just using regular LLMs, uploading a file, and the outputs from the LLM isn't always as accurate as we'd like them to be. So he started exploring the code interpreter. So right now, Ilya, you're showing us a demo of a prompt that you've asked, and the output and the trace of that LLM's output in Bedrock agents.
In Bedrock, yeah, in the managed agents environment in Bedrock, correct. So this was working, and the customer was very happy. The only feedback that we consistently got was that it's slow. It takes time. I mean, this process right here that I asked this simple question was usually around 1.5 to 2 minutes to get back.
And what kind of what's the scenario for the customer? So you've got, 1 to 2 minutes that's a little bit of time, but it's not that much time if it's an offline task kind of thing, but if it's built into a user interface or a website, then yeah, that's super slow. So what was the kind of scenario that this would be used in?
It's exactly the latter. So this scenario is that this is an interactive chat interface, and people are uploading any file in any design, and the only requirement was that it's going to be Excel. So it very, very vague, very ambitious, I would say, for as far as requirements go. That upload anything, hopefully get an answer.
Cool. So you got down to you're at 1 or 2 minutes. It seems pretty slow for the customer.
Right.
What was your next move?
So I didn't have a next move until we introduced AgentCore with Code Interpreter this past summer. The benefits of using AgentCore, and specifically Code Interpreter, is you can control yourself how the code is written. So if you look at the code, for example, in our trace here, you have a very nice looking code. You have comments. You have a lot of different things. You have print commands that might be used, might not be. But all of this, what's important to remember is whether it's comments, new line characters, everything that's designed and you see here as output as far as code goes, takes time to generate. As anybody that's used any kind of LLM, unless the text is cached or held until the full response is ready, you see how lines get outputted slowly. That all takes time. But if you can prompt a model to write code more efficiently, not only will you get code that executes faster because it's more efficient, but the generation of that code will become a lot faster when you say, I don't want any comments. The code doesn't have to be clean. The code can be a total mess because no one's ever going to see it, but it has to work as fast as possible. So when you put in your own rules, when you hint to the LLM of how to write better code, the results come out a lot better.
So what were some of the optimization techniques did you try to help reduce the time?
I would say the biggest things is hinting at how to approach these problems. So when you ask an LLM a general question, it's going to reference all the data that it's been trained on. When you tell the LLM how to behave to begin with, give it hints about how to process these files, because the only thing we really know is this is going to be an Excel document. But we do know some things about Excel documents. We know that there are sheets. We know that there is most likely columns on the first or third or fourth row. Now, obviously, that doesn't fit for everything, as I showed you in the example, but we know how to give hints to a model that's going to write code that specifically will interpret Excel documents.
I
We
want
have
to take a minute to respond to some folks in the chat.
Yeah.
First of all, we've got someone here from Nigeria. Awesome. I think that might be one of, I mean, Australia is pretty far away. Nigeria also pretty far away. Welcome. This might be my favorite I've ever gotten on our Twitch channel.
Let's go. We need to take a
Right on. All right. And then Daily Push has a bunch of questions. So I don't know if Daily Push is a he or a her, but they ask, did you try any different models, or did you use multimodal? Which model are you using at the moment?
So there are different models that write code differently. From the experiments that I've done, I found that Sonnet 4.5 has the best, at least today. It might change, tonight or tomorrow, but as this solution is working today, Sonnet 4.5 is able to write the best and most efficient code for this particular solution. Now, I'm not using any kind of specially trained model. Everything is just frontier models right out of the box. So right now, I'm using Sonnet 4.5 to write the code. Now, I'm glad you brought up this question of different models, because one of the other efficiencies that you can do is that you can use different models to do different steps within this solution. So for example, I have Sonnet 4.5 to write the code, but I'm using Haiku 4.5 to actually analyze the response and see if the answer is good enough to return it. And that's where the benefit comes of using something that's not completely managed service like Bedrock Agents with Code Interpreter, and using a custom code to generate the code, or a custom model, actually custom prompts to generate the code, and then using a completely different and faster model to interpret the results and see if the results are good enough to return to the user.
Nice.
So Ilya, you've mentioned a couple different terms a few times: Bedrock agents, AgentCore. So can we differentiate, what is which one? Are these capabilities, is the code interpreter capability available in both? Let's chat a little bit about that.
Yeah, of course. So Bedrock Agents was introduced first. It is a completely managed service for hosting agents. You have very little control of how your agents run when you compare it to AgentCore. So with AgentCore, you have to create your agent using a specific way in Python. You turn that agent into a container in ECR, and then that container agent runs in AgentCore runtime. So AgentCore comes with, I think, 7 different tools or features that you're able to use. One of them is runtime, which is where your agent can actually run. Now, a lot of the features in AgentCore don't have to be run by an agent in runtime. For example, this solution that I have is a Python script on my computer, and I generate the code using Claude 4.5 in Bedrock, and then I use AgentCore Code Interpreter to run that code, just using the Python AWS SDK. So I'm not deploying anything to AgentCore runtime as the solution is now.
Interesting. So what do you like, if you share this with your customer and they are happy with it, what do you think the architecture looks like to scale this thing? Like, what does that start to look like to you?
I guess it depends on what the goal is. If the goal is to simply provide a chat interface, I think an agent would be overkill, just because it's not required. That solution works fine without. You can run the code, you can run it in a Lambda function, and then have that Lambda function use the same Python SDK that I'm using to reach out to Code Interpreter, to reach out to Bedrock, wherever it needs to reach out to. Can you make this an agent? Sure. It could be an MCP tool if you wanted it to be as well. It's all about what it's all about what the customer wants to do at the end of the day.
So you started off with 2 minutes of latency. How much lower did you bring it down?
So from my experience, I've the same exact question has come down to about 30 seconds.
Impressive.
So there's a substantial benefit and speed gains with the new solution because you're optimizing how the code is written, how it runs, and how the results are interpreted. You also have more control in terms of the number of steps. So as you can see with the solution that I'm sharing on the screen right now, there are seven steps, right? 7 total steps to get the final answer. When you're controlling it and when you're optimizing how the prompts are written to Bedrock and what you're getting back and interpreting the results that are coming back, I got this down. It executes in about 3 steps. And that's where the time savings come from. There isn't just one thing that automatically makes the solution faster. It was definitely an iteration of trying and failing miserably sometimes in getting an answer. So I can talk about the code if you like, or I can show you what the command line interface looks like, but whichever one.
Yeah, I'd like to see that. I'd also love to hear a little bit about like your working process, like the kinds of tools you like to use, how you get from an idea into something that works. Like what's your go-to stuff for that these days?
Yeah, so when I was actually working on this, I was not using any AI tools. I was just, because of my engineering background, I have a lot of experience with development. And so I was just looking up documentation and putting in the code that I needed to put in. I would say at this point, I don't know if I would be writing a lot of code. I'd probably be talking to Kiro CLI or some other agentic IDE to come up with this solution for me, and optimizing that solution either with the help of the agent or myself by looking at the code.
Got it.
So here's a simple view. I have a few questions that I've asked. So for example, here's where I'm sending the Python document. I send the prompt, or this is the Python script. I send the file, and here's the prompt. What is the average closing trading price for brand one? So this is something that we spoke about in the beginning. You have a column, you have a completely arbitrary Excel document with multiple sheets. And one of the things that I output here is what is the thinking that these models are doing in order to get the answer. So you can see with iteration 1, Claude wants to investigate, I've not fully answered the question. While the stock price history sheet contains closing price data for brand 1, the data structure shows the sheet has malformed headers, column names are generic, I can see close data exists, but I need to properly parse, determine the full extent, etc. And it goes on and on to get it gets more and more complex. And here's the code that it writes itself to actually get the information out of Excel. Now, for example, here you see that Pandas is going to use the OpenPy Excel library or engine to read this data. I gave it that hint. So what I saw from experience before hinting at that engine is it would either try to use an engine that's not pre-installed in AgentCore, or it would use this after wasting valuable steps and processing time, realizing, oh, I should try to use OpenPy Excel. So this comes back to hinting at what engine should be used for this particular use case.
So,
and then at the end, all this code is written, and after 35 seconds, I get an answer saying that this was the average closing trade price for brand 1 is $93.68. And that the closing price had other brands there. So it had to parse out that I was specifically looking for brand one, which was from my original prompt.
Ilya, we have a question here.
Yeah.
Someone, Chandra, is asking, does the agent already have access to the data for each question that you ask it? Is there a cache? How does that work?
So the first step that's a great question. And let me bring up the code, because I'm more than happy to share this. It is pretty interesting. So as with every Python process in the world, we start with main. We parse out what is being sent to the script. So we look for the Excel document, we grab the prompt, and we grab the max iterations. Max iterations by default is 10. And what this number is controlling is how many times do I actually want the LLM to try to parse out the answer? Because if it keeps going, let's say I uploaded something incredibly complex and there's just no way that an answer is going to come, I do want a timeout, because not only am I going to pay a lot for constant processing, if this has to do 100 iterations, it also makes for a terrible user experience. So if I can't get an answer fast enough, whatever enough means in your world, return a response saying, I can't, we run out of tries or something like that. Once we actually make sure that we have all the data we need, and here's where the prompting is actually very, very helpful and specific to our use case. So first, you're telling the model to come at this from a data analyst point of view. You're saying, analyze this data and the prompt that's being sent by the user. And then you give it some hints, and you give it some helpful information that will speed up the process and stop the LLM from trying to come up with this on your own. So you must write Python code to grab the sheet names and run through each sheet to determine the structure. That's the very first thing it's going to do. You must determine which sheet or combination of sheets to look at and then write the code. So as you can see, there's a few of these. So what happens next is it calls another function, which is Claude Code, which is actually to create the code to run based on what iteration number. So for the first iteration, I'm just going to send it the Excel file. For every subsequent iteration, I'm going to say, write the code. So when I send it the Excel file, I'm going to give it another hint. Use the Python pandas library to determine the sheet names and structure for each sheet. Again, I'm giving it a hint to save time from this LLM to try to figure it out on its own. Now, the real optimizations. Sorry, was there a question?
Yeah, I feel like I'm just having an aha moment right now, which is that, so you've got this script that you've built out to basically, tell Code Interpreter what it is you want. And then Code Interpreter is writing code for you based on your prompt, executing the code, or sending you the code back, and then you execute it, or where like I'm almost there. So
yeah, and I'm almost there as well. So that we're going to get to that in just a second. So
okay,
here is where I'm going to tell Claude Sonnet 4.5 specifically how to write the code. So act as a senior software engineer. You must only return the code. You must specify engine OpenPyXL for opening the Excel document with pandas. You must not include anything before or after the code, because these models can include commentary or examples of how to run the code or something like that, which again takes time to generate, takes tokens, and delays the ultimate response to the user. And you must not include any comments in the code. So this is where the code is actually written. I then return the code to the main function, and then I execute the code. So executing the code in AgentCore means that I take the code that was generated by Claude Sonnet 4.5. I do some optimizations for it, like inserting models that I know it's going to need by default, if they're not there already, uploading the actual document that we sent in initially. So you can upload documents to Code Interpreter that it's going to be running the code against. And I do that only once, because on the first iteration, you have to create a session for Code Interpreter to run in. When you do that, that means that you don't have to start a session every time. And that, again, creates optimizations. That also means that you only upload that file to Code Interpreter once instead of every time. So that file is now available for every subsequent run as long as you reference the correct session ID. And once that code runs in Bedrock AgentCore Code Interpreter, sorry, our names are not great, you get the response back, and then you send it for analysis by a totally different model. Can you use the same model? Absolutely. But you do send it, in this case, to a different model to analyze if the answer is there.
Got it.
Awesome.
So are you basically generating a new, like Code Interpreter is generating code for you on the fly, essentially,
Yes.
for every new request?
For every request, yes. And requests that it deems the new code should be generated for, meaning that I have no real control about what that code is going to do. You ask it, you give it a prompt, you give it some hints like I do here, and then you hope that the model has been trained well enough to write the correct code. And that's where I like that somebody asked, which model do you use? That is definitely a part of the experimentation with this kind of development. There are some models that are very, very amazing at interpreting text, but completely fall apart when you actually try to generate code.
I mean, that brings me to my next, like, obvious question is, how do you deal with like code safety and security and stuff like that? So you're basically asking an LLM to generate code for you, and then you're almost immediately executing it, probably with not a ton of review in between, or if any. So
no review at all.
Yeah. So how does that work? Like, what's the security and, kind of thinking through that part of the process?
Yeah. So that is actually up to AgentCore, the code interpreter tool within AgentCore. So that is a completely stateless environment, as long as it has the state as long as you're referencing the same session. But that's really the only reason I do that, is so I don't have to upload the file multiple times. But it is a completely isolated code execution environment. If your agent, you can set rules and access as to how that code execution is done within Code Interpreter, but it is a completely isolated environment. It has nothing to do with where you're running this particular script that you see on the screen. It's completely within AWS and separate from wherever your other code is being executed, or where your agent is running, if this is in an agent or an MCP. So it's completely separate.
So it's in an isolated environment. And then in terms of like a time limit, so say you have a very large Excel file, the one that you show just has a few tabs, right? Has your customer had tests for, larger files? Like, how was the experience there? Or in terms of, how long it would take for, a file to run that's much larger? Do you have any data points on that?
So I would say that's still dictated by the user experience. If you upload a large file and ask a question, a very, very vague question, it might take more than 10 iterations. Now, do you want the user to experience the delay and wait for an answer? Or do you want to get back to them and say, please narrow down your prompt, or can you give me a hint about where to look for the data? That, again, depends on the user experience that you're going for. I have not heard of them uploading very, very large files. I do know that they are using this in production very successfully. People are pretty happy with it. So I'm guessing that they've found a happy path to how they want to, how much time they want to let the model run for before they say, look, give up, we need to adjust the prompt.
So we have about 5 minutes left before we wrap up. I got to ask about the cost. Is this an expensive solution? Or, how much does it cost every time I analyze a spreadsheet? What have you learned so far in your journey here?
I guess everybody has a different definition of expensive versus cheap, right?
Yes.
To be honest with you, I haven't done a lot of cost comparison. Again, at the end of the day, you're paying for tokens and you're paying for execution time. So the amount and execution time, not of this script that you see on the screen, but of the execution time of the code that's written by the LLMs. So again, that's all those things are very different. The cost will depend on the load of the application. If you're processing thousands and thousands of Excel documents per day, it can get up there, but that'll be the same as if you're processing thousands of text documents per day and asking questions against those as well. Unfortunately, this data cannot be vectorized just because tabular data is not ideal for vectorization like a regular text document is, or a knowledge base with all the data that's saved in there. So this data has to be processed with using libraries like pandas or something similar to get the intelligent data out.
Thanks, Ilya. I know we're here towards the end, so just want to do a recap as we're closing off. So thank you so much, Ilya, for your time and walking us through your solution on how to, go through a spreadsheet data. Folks spend hours and hours going through this, so using AI to accurately provide analysis is really valuable. So thank you for going through that solution with AgentCore Code Interpreter.
Thanks for having me.
One question that I have for you is, where do you see this solution being posted? Like, do you have any guidance or documentation for folks that have joined? Like, how can they go ahead and start using this today?
So this is not published. I hope to get this solution out and published very soon, but unfortunately it's not published just yet. The thing is I'm not doing anything secret here. Now that you know the general strategy, ask an agent in Kiro or Cursor or Claude Code to write this for you. None of this is secret that I've done. It was just, I had the opportunity because my customer asked me. Yeah, so if I was to approach this now, I would definitely be using an agentic IDE to do a lot of the coding for me, where I can stick to the strategic goals and the planning and leave it to the agent to write the code for me.
Nice.
Awesome. Cool. Thanks so much. So we're coming up on time. We're going to be back next year. So in 2026, we're planning to continue the show. I'd love to hear if anyone wants to throw in the chat any ideas for our future episodes. I know we talk about quite a lot of things here on the show, but would love to hear any ideas quickly before we wrap up.
I feel like you have to do something on agentic development.
Oh, yeah.
Yeah, I think you might be right. It seems to be most of what we talk about.
Well,
I think it's time.
Yeah.
I think next year we definitely might start with some physical AI topics. That's something that's very new, up and coming. AWS has released some blogs and a stance on it. So we're going to explore that next year as soon as we kick off 2026.
Like robots. You're talking about robots, right, Ria?
Like humanoids. Yes.
Humanoids.
Okay.
Yeah.
That sounds pretty cool.
Yeah. Yeah. Any feedback or any ideas for future episodes will be on here. So please leave some comments.
Nice. Cool. Thank you all. Daily Push, there's so many comments. I'm going through them still. That's a lot of good stuff. Thank you so much for that.
Thank you.
Thank you all.
Thanks, Ilya. Thanks, team.